So, hi everybody, welcome to a slightly off-schedule TST meeting. I wanted to move it to morning so that Andrea could attend. We'll probably need to do that every other week at least. So today I wanted to talk about a couple of things. Well, I have one thing specifically that's discuss possibly extending the device provider interface to allow retriggering connections from the controller side. And the second topic is something that Brian put up. It's a recent security alert regarding the vulnerability in OpenFlow protocol. And Brian can talk more about that and also discuss the fix that he put together last night. So with respect to the first topic, which is the extension of the device provider interface, what motivates this? First of all, let me share screen if I can do that.
I'll make you presenter, Tom.
Thank you. Excellent. Can you see that?
Yes.
Okay, great. So what motivated this was following. The device driver framework is intended to allow injection of new device drivers into the system on the fly. So, and it certainly does that. But it was also intended, clearly, in order for it to be useful, we need to have a mechanism through which we can actually change which device driver is bound to a specific device at runtime. Now, this may not necessarily mean that it will be without disruption to operation of that device, but it should certainly be possible to do that. And we did have a mechanism which allowed us to administratively remove a device, which would trigger the providers to effectively reconnect and to clean up whatever was there previously from, with respect to flows, meters, groups, and other things like that, and effectively to kind of establish the connection with the device anew. And as part of that, the idea was that this was also rebind the driver that was newly installed or newly configured. However, there was a problem in the OpenFlow provider which actually prevented the override, and any device driver override was effectively not picked up. And it had to do with the behavior of the get driver call, which relied on the device annotations to be picked up. But the problem is the device driver provider picks it up at the time before the system knows about the device, and hence there is no annotation, and which meant that we would always rely on a primordial information, which is the hardware, software, and manufacturer information to find the correct driver. And if there was an intended override, it was never picked up. So yesterday I've put in a fix to do this, and so now we're actually picking up the correct driver. So that's good news. So that is all fine, except in the process of...
Thomas, I think picking up the correct driver always worked, as long as the configuration was there before the device connected. But the problem was that we couldn't change the driver at runtime.
So at least what I saw, Jono, was the following. The pipeliner was picked up correctly, because the pipeliner was picked up after the device was already in the system. But from the OpenFlow driver, at least I replicated the issue where no matter what I would annotate the device with, whether I would use the device annotations or whether I use the network configuration, after the device removal, the OpenFlow provider would come up and pick up the default driver.
Yeah, I know what you mean. I think I've seen it before as well a long time ago. But yeah, there's different ways of picking up the pipeliner and the OpenFlow driver. Yeah.
Yes. So that actually would cause a disparity. Plus, there was a defect in the OpenFlow provider where removing the device administratively would not, it was done at the level where not all of the collectors were properly shut down, which meant there were some port statistics collectors that remained in a system that kept then resulting in repeated warning messages being emitted. Basically, it was a threat leak. So my point here is that in thinking through this, I was wondering whether we ought to, other than rely on a device remove event, whether we ought to possibly extend the device provider interface, which is shown on the screen here. And which, as you can see, currently has just means to be able to trigger a probe to see if the device is there from the core to the provider. We can notify the device provider to about this controller side induced role change. We can check whether the device is reachable from the controller, and then we can also administratively change port state. But there was no kind of a direct or explicit method for the core to tell the provider to force a reconnect or disconnect of a device. Previously, we were relying on an indirect, so currently we are relying on an indirect method of device removal event, and this means that the providers have to listen to device events, and when they detect a device removal event, they have to basically do the disconnect and then reconnect if the device remains available. And while what we have today works fine, it is kind of almost a hidden behavior. And I was wondering whether we ought to add a method in here to make that behavior more explicit and that contract more direct between the core and the device provider.
Yeah, I think that makes sense to me. I think just for the reason that you said, right, it makes it explicit that we expect the providers to be able to handle this functionality.
Right. Because I actually started on that route, just as a background. John and I talked about this a couple of days ago offline. And John pointed, I actually started on route by adding a trigger disconnect method. And John pointed out that we actually had a mechanism already through the device removal event, which is something, I'm fairly familiar with the system, but that, if that escaped me, that might be not obvious to people who are new to the system also. And so that's kind of what
it just means that like some providers may pick up that event and implement the right behavior, and some may not, right? Whereas if you put it in the interface, and that's explicit that the core expects that all providers can handle this.
Exactly. Yes. Now, obviously, right. So this is kind of what I'm leaning towards doing. Now, obviously, we would make the new method have a default implementation with which would throw an exception. So that way, we would at least satisfy the contract, but then we would also at runtime have a direct indicator that this particular provider does not implement that method. And maybe there would be a signal for us to go back to it and implement it. So that was what I was thinking of doing. So if there is no objection.
I like the proposal, Tom. A couple of questions. One would be, since we actually do have the mechanism of the device removed triggering some of this, and I'm thinking about the implementation that I've done in the netconf device provider, that actually handles disconnection of the device by listening to the device removed event. I was wondering if we could have a default behavior that actually triggers a device removed event, but maybe that's a bit too much.
I'm not sure I followed, Andrea, sorry. So can you repeat?
My suggestion was that since some of the providers actually do support removal of the device, and they do get triggered by the device removed event, I was wondering if we could provide a default implementation that does that.
I see.
But maybe it's a bit overkill.
Well, So as part of my initial code change to cover this, as I mentioned before, that involved extension of the interface. And because I did that, I actually swept through a number of the providers, netconf provider included, and I made changes to them to satisfy the interface.
Mm-hmm.
I think it would be better, I think, if you were to there's not that many device providers that we currently have, different providers. My thought would be that we should just sweep through those and make sure, basically migrate their handling of the disconnect to the trigger reconnect method. And in some cases, we could completely eliminate the reliance on the device remove event, at least within the providers themselves. Now, within the manager itself, which is the manager is what actually does interact with the providers. Within manager itself would still be triggered by device remove event. So right now, at least externally, the only way to trigger this invocation of this interface would still continue to be the device removal action.
Okay, the device remove of the device admin service.
Yeah. So exactly. So as a consequence of calling the device administrative device or remove device method, which I think is if I were to device admin service.
Yeah.
So still, as a consequence of calling this method, which is handled by the device manager, that would then turn around and call the appropriate trigger reconnect method on the appropriate provider. That was the thought.
And then how would we handle the actual removal of the device from the store? Because if we were trying to reconnect, are we assuming that we are taking it out of the store, disconnecting it, reconnecting it, and re-putting it in the store?
Yeah. So what happens right now, the invocation of this method that's highlighted in here will actually go first through the store. The store will be instructed to remove the device, and as a result of the store getting this, handling this action, events will be dispatched to all of the nodes in a cluster. Basically, the delegate will be notified, which is the device manager will be notified on all of the nodes. Right? You call this method from one place. The store gets it, store propagates it outwards, and then the delegate gets called on all of the nodes in a cluster, and every single device manager in the cluster will then notify the respective provider to force a reconnect.
Yeah.
Okay, that's basically what will happen, except this time it'll be direct invocation of a method on a provider rather than indirect event notification, which is what we are about today.
But we would still remove the device from the store.
Yes, exactly. Yes, so it continues to be a fairly big hammer, and we can perhaps consider, having a little bit, having a kind of a smaller hammer, basically where the device administrative service could include eventually, if you want, a method to just reconnect the device or disconnect the device here without removal. However, I think right now there are other parts of the system which require that their state be cleaned up as part of the transition between drivers. And I think we, just for safety reasons, until we handle all of the nuances of cleaning up that state, probably the safest way is to insist that all the traces of the device are removed from the system and then re-added as part of the device effectively being rediscovered.
Agreed.
Does this trigger cleanups in other subsystems, like the flow subsystem or the group subsystem?
Right, and so the flow meter and groups, I think, are handling the removal of the device already, and the flow objective.
In response to the mechanism is the device removed event?
Yeah. Yes. Correct.
Okay.
Yeah. So I feel better. So the thing is, the rest of the core subsystems, for them it's okay to be directly dependent on device notifications because we want to have loose coupling there, right? But I think the boundary between the device manager, the core of the device subsystem, and the southbound part, which is the providers, should be a little bit more explicit and direct. That was what I was thinking.
So after calling the remove device event, from the store, the device object disappears. So if that's like, so in that case, for other subsystems to react to that device event, they would no longer have access to the device object. So wouldn't it be a bit challenging for them to retrieve the appropriate behavior if they needed to take the removal action? Or
well, we'll deal with that today already, right? The device event. As the subject of the device event is the device itself.
Ah, okay, so it has a reference to the last device, I guess.
Exactly, yes. So it's kind of a shadow entity, but it's still a full object. And we deal with that complication already. The existing code already deals with it.
The only problem that removing and re-adding in a fairly concise amount of time might bring is that, let's say, an app reacts to the device removed event by removing the device, removing some state it internally keeps about the device, purging the flow rules. And while this is done, the device comes back again. If not properly handled, this might issue some, well, consistency problems.
Agreed. Yes, but that is remains. I think that the problem already exists.
Yes.
But what I mean is that we're not introducing a new complication. That complication is already there.
Agreed. Yeah, we might want to look for it in some of our existing applications that might not take care of it properly.
Agreed. Yeah. So
the other thing I'm noticing is that currently the flow manager only removes devices if a particular flag is there, and the flag is called purge on disconnection. But it seems that the behavior of removing a device is around the behavior of a device disconnecting, right? So I wonder if we want to go through and change that behavior in the flow manager and the group manager.
Right.
Because when a device is removed, completely removed administratively from the system, then we should clean up all the state associated with it, right? I think this is probably the reason why I was seeing what I was seeing that originally prompted this discussion. Because the existing, even though the device had been removed, I'm guessing that the old flows that were created by the wrong pipeliner were not removed, and they remained in the system when the device reconnected.
So I thought the flag was by default. This is this one, right? Yeah. See, I thought purge on disconnect. Oh, it's all by default.
Yeah.
But also disconnection to me is not the same as a device remove event.
Yeah, that's not the same.
So we're having them the same way.
That probably shouldn't happen. Yeah.
I believe this was set to false by default because we wanted to reinstall every rule that was previously on the device to make sure that, let's say, some traffic that or an intent that was asked was still installed on the device.
I think when a device disconnects, what you want the behavior of keeping the flows so that when the device reconnects, you reinstall the flows. But if the device is removed, I think you want to, by default, you want to remove the flows.
Absolutely, I completely agree. We need to divorce these two case clauses from each other.
And I think this might also come in handy with the segment routing application, because right now segment routing by default purges on this connection. But we might rethink that if we split these two.
Yeah, so I think to start with then, probably what we need to do is then, okay, So only extend the device provider with new method, invoke that method directly as a result of a device remove event from device manager. And then we need to sweep through some of the other subsystems like the flow rule subsystem here to make sure that the device removal is handled appropriately. Here, I think we need to divorce these two cases, and in case of device remove event, need to unconditionally remove the devices, remove the flow rules, no questions asked without any ifs and buts, and then on device availability change can be handled as it is right now, which is that's what you were suggesting, John, right?
Yeah, that sounds good.
Okay, and we need to probably look at the other subsystems like groups and meters to handle them the same way. Okay.
Yeah, it looks like groups is the same as flows right now.
Okay.
Mm-hmm.
All right, I'll make these changes on the master, and then we can investigate. I'll try to do them as concisely as possible so that we can hopefully cherry pick it to 13 and 12 as well, because I have a feeling this may be required on the Comcast as well. All right, so if there isn't anything else on this, I think that covers what I wanted to discuss. Does anybody have anything else on this? If not, I think we can pass the ball to Brian to talk about the security vulnerability then. Andrea, do you mind doing that?
Yeah, let me make him presenter. Brian, I guess you have the floor.
Thank you, guys. Cool. So you guys can see my screen?
Yep.
Yes.
Cool. We recently became aware of a new vulnerability that impacts OpenFlow channels if proper steps are not taken to achieve authentication authorization for controllers. And so just a little bit of background. Basically what happens is by default with OpenFlow, there's no transport layer security requirement. Any device can connect to the controller. And the way that the controller identifies the devices is using DPID, a data path ID. So one of the things that people can do to prevent anybody from connecting to the controller is to require that the switches, which act as the clients in this connection, provide a client certificate. However, if a client certificate becomes compromised, or if one of the switches in the network becomes compromised, it's possible for an attacker to basically connect as any device in the system because there's currently no link between the DPID and the client certificate from the perspective of the controller. So the vulnerability basically outlines in the absence of authentication authorization, meaning in the absence of mapping specific client certs to DPID numbers on the controller side, this means that somebody with a client certificate that's generally accepted, or somebody with without using TLS or OpenFlow connections would be able to spoof any of the OpenFlow switches by just sending back the DPID of the switch they want to spoof in the features reply. So to mitigate this attack in ONOS, we're working on a patch, and I can talk through a little bit about the pieces that are involved. So the first thing that we need to do is we need to add a new piece of configuration. I chose to do this as an OpenFlow device config. So rather than augment the basic config or anything else, basically this just adds an OpenFlow section to the device area, and then it adds a specific key alias. It gets registered in the key store that's already required by OpenFlow to enable TLS. So once a key gets added as a trusted certificate, that key can be mapped to a specific OpenFlow device, and then that gets added to the netconf config registry. So today, when a switch connects to the ONOS controller, the messages it sends are put through something called the OF channel handler. And this is a state machine that accepts certain OpenFlow messages in certain parts or phases of the connection. The part that we're interested in is the OF features reply. So when the OF features reply is sent, the DPID for the switch is included in the DPID for the switch is included in the features reply message. What happens today is the OF channel handler just accepts this DPID, and it will construct the switch object based on this DPID and register it with the provider. But to mitigate the attack that we've talked about, there's a little bit of extra steps that we introduce. So the first thing is the OF channel handler asks the OpenFlow controller to verify the DPID. So it provides the peer certificate, which is the client certificate for the switch, as well as the DPID number to the controller. The controller can then query the net CFG registry and ask for the device configuration, specifically the OpenFlow device configuration for a given switch and DPID number. When it gets that back, it can verify that the key that's provided in the device config, i.e. like the alias here, it can extract the client certificate from the key store and then verify that it matches the peer certificate that has been returned as part of the TLS session. Then in response to this verification, on success, we update the state machine to move on to the next message type, and that proceeds basically as normal. On failure, we can just disconnect the device. This would mitigate somebody's ability to spoof the connection for a specific device without the specific client certificate required for this connection. So the goal here is that if you want to run with OpenFlow in the unsecure state, or if you don't want to provide specific key aliases for a given OpenFlow device, the default behavior is left as fail open. But in cases where somebody has gone through the trouble of configuring a specific alias, then the connections will be blocked. So this code is already implemented as a draft patch. Probably be promoting it to a real patch or a public patch this afternoon or this morning. And where I guess we can solicit feedback is kind of in the overall delegation of behaviors in this model, and also the integration of the new configuration. So any comments or questions? Anyone still there?
I don't exactly remember, but I remember somewhere in the OpenFlow controller that maintains a map from DPIB to the switch object kind of thing. So, but this happens before the state machine shift to active, so that will not be overwritten by this sort of malicious DPID claiming device connection. Am I correct?
Yeah, that's correct. The transition or the generation of the switch object happens after this stage of the state machine.
Okay.
I can actually show you, let's look at the state machine. So the state machine's in OF channel handler. So the stages are, for init, wait for hello, and then the next stage is wait for features reply. And so it's in wait for features reply that we'll now, instead of just blindly setting the DPID and moving on, we'll actually set it via a method. This method then is responsible for doing the checks. So first we get the SSL handler for the Netty connection if it's present. We'll ask the handler for the session, and from the session get the peer certificates, and then pass the peer certificate to the controller to make sure that for this DPID the certificate's valid. The actual call to create the switch object happens a little bit later in the state machine. I think it happened exactly where, but it's somewhere in here. H.switch here. So the switch object is instantiated upon getting the description set. So yeah, this wouldn't, in cases where we disconnect, we're disconnecting I think 2 or 3 stages, I guess 3 stages earlier in the state machine before we would instantiate the malicious objects and overwrite anything.
I see. Thanks.
Yeah. I tried to talk earlier, but I mean, I did talk earlier, but I did notice that I was on mute. So I looked at the patch. It looks really good to me. One thing though, in retrospect, I was wondering if we could, after all, piggyback on the basic device config, because I didn't realize earlier when I was reviewing it that we actually do have a device key ID inside the basic device config, which is intended to be an explicit binding to a specific key. Now, this key ID does refer to a key ID inside the device key subsystem, but I'm thinking that since it represents the same intent, really, we could probably just use it also as a key alias directly into the keystroke.
Isn't this?
So yeah, I guess I saw that in the basic device config, but I was worried about
Collision.
being a use case that would derail existing usages.
The thing is,
but if you don't think it'll derail existing usages, we can certainly do it that way.
Yeah, it's a minor point. I think overall scheme is sound. So I think how we inject specifically the information into the controller can then potentially vary a little bit.
Let me just pull that up now and we can take a look at it.
Because the device key subsystem was put in place precisely for this reason, but it was intended to be protocol agnostic. So, which is why the device key abstraction is somewhat opaque, and you can have different types of device keys. And so this is simply an alias into it. It's still continue.
So the device key ID.
Yeah, the only thing is the device key ID is a concept that might not be visible to the provider. So maybe not. Maybe just stick with what you have, because that way you don't want to.
Yeah, I guess I can take a look at where the usages are for device key ID. The other interesting thing, it says down here that device credentials and keys are supposed to be in separate config. And so the pattern I followed was netcom device config. So in this case, you have IP, port, username, password, SSH key as a netcom specific config.
Right. Yeah.
Which is why I went in this way for the OpenFlow device config. But I guess my thinking is that really this config is only used in one place. And if we want to move, if there's somewhere better, or we can coalesce or collapse this, we can certainly do that. But it's only used in the controller, specifically in the new method that I mentioned, which is valid certificate. So in this case, as I mentioned before, if the netconfig service isn't available, we'll fail open. If there's no configuration for a specific device, we'll fail open. If the alias for a specific device is not present, we'll fail open. And then basically we'll ask the key store for the certificate that was presented, and then just verify that the certificate matches the peer certificate that's presented by the switch.
Just keep it like you have it, I think, because the idea for the key subsystem was that it kind of provides a higher level abstraction and potentially simplifies the configuration. But we can always bridge the gap between the protocol-specific configurations and sort of the protocol-agnostic ones at a later time through a different mechanism. So just keep it like that. Yeah.
Yeah, I figured that this approach would be probably the least likely one to disturb any existing behavior or functionality.
Correct. Yes.
And given sort of the idea that we wanted to try to get this patch out quickly to the community, I wanted to kind of minimize the testing required and regression tests that we should need to do to make sure this.
Yep. Good call. Yep. Agreed.
Just from curiosity, but this CVE something, is it now open to general public, or is it still not?
Yeah, the CVE has been open to the general public, and ONF has specifically been getting requests about it from external parties at this point.
Yes, I see.
Yeah, I think it was made available to the general public 2 days ago, or 3 days ago, earlier this week.
I see, thanks.
Yeah. And I think the way it's done, we should be able to cherry pick it in the last couple of releases as well.
Yeah, but actually the interesting thing is that I reached out to the author, and every OpenFlow controller that's an open source that they looked at suffers from this DDoS vulnerability. This isn't something that the open source controllers have focused on. Some don't permit using to enable TLS, and the ones that do enable TLS keep the TLS authentication and certificate management separate from the OpenFlow protocol implementation. So kind of like we did. We do TLS in one stage of our Netty pipeline, and then OpenFlow handshake in a separate stage. This patch would bridge the gap between the two, and other OpenFlow controllers would want to consider implementing something similar if they did not want their controller to be vulnerable to this attack defined by the CVE.
Yeah, so this basically will allow containment of a breach of a single certificate. Yeah.
Yes. Yeah, authentication says, are you who you say you are? And if you want to know if somebody is who they say they are, then everybody should have a different identity. So that is advocating for different client certificates for each device. And then authorization, are you authorized to connect or perform a specific action? In this case, the switch is trying to, become registered as a device in the system. Only a specific identity as defined by the SSL or TLS certificate, SSL certificate, should be authorized to create a device with a certain DPID in the system under certain security policy. So if your security policy, wants authentication authorization, the two need to be linked together. And one of the challenges is that today, and in many OpenFlow controllers, the two are not linked.
So just to be clear, though, once you breach a certificate, you can then impersonate the switch whose certificate you breached and continue to sort of hijack or occlude the device in the network. But that's all you can do. You cannot hijack other switches.
Yep. Yeah. So basically what it's doing is it's creating a tight binding between a client certificate and a DPID so that a device that connects with a specific client cert can only perform the actions of a device with a specific DPID, which would prevent somebody who gains access or spoofs gains access to one client certificate from spoofing information about other DPIDs for which not the registered.
Yeah.
And if somebody wants, they can still use the same client key across a subset of devices or all devices in their network. But basically what you're doing with this configuration is you're saying that for this specific key, my key, for every device that it's registered to, this key should be authorized to register the following DPID.
Yep.
We may in the future also want to explore a strict mode where all those places I said we fail open, we fail closed, which would mean, because today, for example, if somebody got access to a client certificate, they could potentially spoof new devices that wouldn't necessarily be covered under configuration. I think we may already have a strict mode which doesn't permit devices to connect with new DPIDs that are not configured. But we may also want to explore a sort of a strict mode in which any failure to authenticate, instead of just returning true, we would return false and block the connection. But maybe I'll add that as a flag somebody can set, and they can set it up when they start the
right component configuration stuff here.
Yeah.
Yeah, that might be good.
Can you add another question though? Sorry, I cut you off.
No, go ahead. There are questions? I guess not. So, okay, I guess we're done with the topic. Can you guys hear me okay?
Yep, I can hear you.
All right, and it just was pretty quiet, so I just wanted to make sure the connection was all right. So thanks, Brian, for speedy response to this. This will be good. So you said you will turn it into a public patch up for review and potentially also enhance it with the strict mode.
I'll try to enhance it with a strict mode and then promote it to a public patch. I was just hesitant to promote it to a public patch before at least agreeing on the overall design, because I think with these sorts of issues, having reviews that sit in an open state for a long period of time just generally doesn't look good,
right.
And potentially poses a vulnerability to people who don't necessarily have a patch yet for it. So I was hoping to get as much consensus as possible around the approach and design and possibly code, so that when I do open it, it can move pretty quickly through the approval process.
Sounds good. So if you can actually do that, sometimes if you can get it okay, sometimes before noon tomorrow, we should be able to include it also in a 12.2 RC.
Okay, I'll try to get it done this afternoon.
Sounds great. Thanks, Brian.
Yeah.
Thanks, everybody.
No problem.
Andrea, if you wouldn't mind uploading the recording to YouTube, let me know when it's there.
Yes, I'll do that. It might take a little bit more time than in the US due to my slow up speed connection, but
No worries.
Oh,
No
good.
worries.
Okay, thanks. Thanks, everybody.
Thanks, everybody. Bye-bye.
Bye-bye.
Bye.